when it comes to industrial automation, you've got these two little devices that honestly make everything possible: inductive and capacitive sensors. Now, they might look the same, but trust me, picking the wrong one can be a really expensive mistake. So today, we're going to make sure you can make the right call every single time. I mean, just look at these two. At first glance, you'd think they're identical. You've got the same metal body, same size, same threads. They're basically twins. But here's the catch. One of them can only see metal, while the other one can see pretty much anything. So how in the world do you tell them apart? And more importantly, choose the right one for your job? And this is not just some academic question, you know? Getting this right means you have a smooth, efficient production line. But getting it wrong? Oh, that can lead to false triggers, misdetections, and your entire high-speed assembly line just grinding to a halt. The stakes are absolutely massive. All right, so let's really dig into this challenge. What we have here are two incredibly powerful tools, both designed to solve the exact same problem: figuring out if an object is there without actually touching it. But, and this is the key, they go about it in completely different ways. Okay, before we go any further, let's get on the same page about one key term. Both of these fall under the umbrella of proximity sensors. And what that really means is they're basically smart switches. They don't need to physically touch something to know it's there. They just sense when something gets close. And that, right there, is their magic. So the real secret to telling these sensors apart isn't anything you can see on the outside. Nope, it's all about the invisible fields they project out into the world. Each one creates a totally different kind of field, and that field is what determines what it can and what it absolutely cannot detect. Let's break this down. It's actually pretty simple. Over on the left, you've got the inductive sensor, which uses a coil to generate a magnetic field. And on the right, the capacitive sensor creates an electrostatic field. So magnetic versus electrostatic. Literally everything else we're about to talk about stems from this one single difference. And I absolutely love this analogy because it just nails the concept perfectly. The inductive sensor, it's like a trained bloodhound. It's been trained to follow one very specific scent, and that scent is metal. It ignores everything else. The capacitive sensor, though, is more like a motion-sensitive floodlight. It's super versatile and will react to pretty much anything that wanders into its path. So let's start with the bloodhound, the inductive sensor. This thing is the ultimate specialist. Its entire world, its entire purpose revolves around detecting conductive materials. If it's metal, it sees it. If it's not metal, it is completely 100% invisible to it. So you might be asking, when does this intense, laser-like focus on metal become a superpower? Well, take a look at this. In environments that are dripping with oil, coolant, or covered in dirt, places where other sensors would be instantly blinded, this is where the inductive sensor doesn't just work, it thrives. This is exactly where that limitation becomes its greatest strength. You know, in a metalworking shop, it sees the steel part, but it's completely blind to all the splashing coolant. On outdoor machinery, it couldn't care less about mud and rain. And in something like a food processing plant, it can handle those crazy harsh chemical washdowns and only pay attention to the metal parts it's supposed to. Okay, the second huge advantage here is just pure performance. When what you need is unbelievable speed and pinpoint precision on metal targets, inductive is the undisputed champion. There's no contest. Get this, with a response time of less than a millisecond, these things can perform up to 1,000 detections every single second. It's mind-boggling, and that incredible speed makes them perfect for tasks like, say, counting the individual teeth on a gear that's spinning like crazy, just to monitor its RPM. Okay, but what about the sensing distance? Inductive sensors, they usually have a much shorter range. And, you know, common wisdom would say that's a weakness, right? Well, what if I told you that in a lot of high-tech applications, that short range is actually its secret weapon? This short range actually gives you some huge benefits. First, for that precision counting we talked about, it makes sure the sensor only sees one gear tooth at a time, not 2 or 3. Second, it gets rid of interference, which lets you pack a whole bunch of sensors close together on something like a robotic arm. And third, it allows for what's called flush mounting, where you can actually embed the sensor right into a metal frame without it accidentally detecting the machine itself. All right, now let's switch gears and take a look at the floodlight, the capacitive sensor. If the inductive sensor is our specialist, then this one is the versatile all-rounder. Its ability to detect a massive range of materials just opens up a whole different world of applications.
Its main advantage is actually pretty simple, but it's profound. It is not limited to metal. So if your target is plastic or glass or wood or even a liquid, well, the capacitive sensor is often your only choice.
I mean, it can see plastic, glass, wood, paper, you name it. And this incredible versatility makes it perfect for jobs where an inductive sensor would be completely useless. Things like confirming that glass bottles are present on a bottling line or counting cardboard boxes as they fly by in a packaging facility. But here, this is where it gets really clever. Capacitive sensors can actually be tuned to see through one material to detect another material that's behind it. And that is the secret sauce for non-invasive level sensing. And as this chart shows, this is a critical ability across so many industries. In food and beverage, for example, you can just slap a sensor on the outside of a plastic tank to monitor the milk level inside without ever touching it. In pharmaceuticals, it means you can have sterile monitoring of liquids. It's a total game changer for any application where hygiene is everything. So how does this see-through magic actually work? Well, it all comes down to something called the dielectric constant. Just think of it as a material's ability to store electrical energy. The sensor is set to the dielectric constant of air. So when a material like water or plastic, which has a higher constant, enters its field, the sensor sees that change, and bang, it triggers. It's really that simple. Okay, so we've covered the specialist and the all-rounder. Now let's pull it all together into a really simple guide that's going to help you make the right choice every single time. This scorecard really breaks it all down. It's pretty straightforward. If your target is only metal, you want an inductive sensor. If it's anything else, go with capacitive. If your environment is harsh, dirty, or wet, inductive is your reliable workhorse. If it's clean and controlled, capacitive is a fantastic option. Need extreme speed? Inductive. Need to see through the wall of a container? Capacitive. It really just boils down to this: durability and speed on one side versus versatility and non-invasive sensing on the other. And don't think for a second that this is some kind of old-school technology. Here in 2025, and for the foreseeable future, these two remain the absolute gold standard in their fields. They're proven, they're reliable, and they're always getting better. So we end right back where we started. But now, hopefully, with a lot more clarity. The next time you see one of these little devices, you'll know about the invisible power it's holding. You'll know the difference between the bloodhound and the floodlight. Your project is on the line. The choice is yours. Which one's it going to be?